In this session and in next few sessions, we will be talking about concepts that revolve around object-oriented programming. We will try to understand that how and why this object-oriented programming is so powerful compared to the other functional programming. So in this class, we will more have a introduction about to this object-oriented programming. We will see that how object-oriented programming is different from functional or procedural programming. We will see the concepts of objects and classes, and we will also go through constructors. So first, when you must have heard about Java, so the very first thing that we are told or that comes in our mind is that that Java is a object-oriented programming language. So first, let's try to understand that what is the difference between functional programming language or procedural programming language and object-oriented programming language. So we know C is a procedural programming and Java is a object-oriented programming. So let's take a problem statement, and using the problem statement, we will try to understand the difference between the two, that what is the different approach of solving a program using the two programming methodologies. So first we have a procedural programming. Sorry. And we have object-oriented programming. So let's say you are given a use case to design a car that has a method of driving. So a car basically that drives, and a car has few things like a car has wheels. So this is the two thing. The car has a behavior that it should drive, and the car should have wheels. What happens that in case of procedural programming, the focus will be on the methods. Like I have to drive a car, so the focus is driving. So here the focus is on driving. So what we will do, we will write a method called drive, and whatever things will be there, whatever function that relates to driving will be there inside this drive method, and we will have a global data wheels. So let's say I write int wheels. Okay. So this is how procedural programming goes. So in case of object-oriented programming, the focus is not on the method, the focus is on the object. So what is the object that we are talking about? So we are talking about a car here. So what we will do, we will create a class car. So now I have a class called car, and the car has two things. It has a method drive, and it has an instance variable wheels. Now you can see the difference in approach. So this is the difference in approach in case of procedural and OOPS. Now let's try to understand that which of them is better and more powerful, or why do we need a object-oriented programming language. So in this case, let's say that a use case comes that design two cars. Let's say the two cars will be Mercedes and Audi. So basically now you have to design two cars, and these two cars will have different ways of driving, and the number of wheels will also be different. So let's say hypothetically Mercedes will have 3 wheels and Audi will have 4 wheels. Obviously this is hypothetical. So what is happening here? Mercedes is having own way of driving and Audi is having own way of driving, and both have different number of wheels. So what this particular programming methodology will do, so we will have a if condition here, that if the car is equal to Mercedes, follow a set of instructions, else if car is Audi, follow another set of instructions. So first let's forget about this as of now. First let's say we are asked to just write a drive function for Mercedes. So what will happen, I will have a global data wheels here, wheels, and a function drive, and based on the value of this particular car, based on what car we are talking about, this value changes and the set of lines changes for drive. Now what happens in OOPS is that I will create a new object called Mercedes. I will have class Mercedes extends car. Okay, so extends car is that. So this is a concept of inheritance that we are talking about. We will talk about this inheritance in detail. As of now, just try to understand is that the car is the superclass and Mercedes is the subclass. So basically what happens is that Mercedes is extending its features from the car. So Mercedes might be a special case of a car, but at the end of the day, it is a car only. So it will also drive and it will also have a number of wheels. It's just that it will have, let's say, a special way of driving. So I will create a different class called Mercedes, and the Mercedes will have its own drive function and its own wheels variable. Okay, now let's say that now I have a new requirement that I have to design a new car called Audi. Now what will this person do? It will add a new condition that if car is equal to Audi, perform a set of operations, and again wheel is a global data, and based on the value of that, based on the type of car, this global data is used. Now what will happen in case of oops? Again a new class will be created, class Audi extends car. It will have its own drive function and own instance variable wheels. Now what's happening is that in this particular case, we are changing the same code again and again. So what's happening is that there are various things. We are changing the same code and again. At one time, it will happen that the size of this particular code will be increased to a great extent, which will result in complicated code. There will be difficulty in debugging. So if an error occurs, so in this case, let's say I'm driving a Mercedes. So if some error occurs with the Mercedes, I'll have to see the same method. I will have to go through the functions to see that what is the problem. So it may happen that I have to go and check 100 lines of code just because we are putting all the functionalities in the same method. Whereas here what happens that if there is some problem with the Mercedes drive method, I know that I have to go to which particular class. Okay, so what happens is that once you have written the code for Mercedes, and you know it's working fine, okay, you have done the testing, you have know that it's working fine. After you add Audi, what happens? You'll have to do the testing again because you're changing the existing code. But here in this case, if I add a new class Audi, I don't have to do the testing in these two particular classes. Why? Because I haven't made any new changes here. So if you talk about production, if you are building big applications, object-oriented programming is something that models more with the real world and is better for programming or application development. Now, this is the difference between object-oriented programming and functional programming. Apart from the benefits that we saw, there are another benefits as well. We will talk about them as we go further. Now let's try to understand the very basics of object-oriented programming. We have already seen a glimpse of it, which is a class. Now let's go on to discuss the base of object-oriented programming, which is objects and classes. So we will discuss objects and classes. Now let's talk about classes and objects. So first let's discuss class. So we have seen a bit of class till now. So let's try to define what is a class. So class is a blueprint or template from which objects are made. So what do I mean by that? So consider an example here. So here we have a class called employee. Employee has name, salary and calculate salary. Okay, so these are just the features of employee. This is a blueprint. This is just a template that if there is an employee, it should have a name, salary, and there should be a method associated that whenever I want to calculate salary of that employee, that should be calculated. So the main difference, if you try to understand between object and classes, is that object is something that exists and class does not exist, because this is just a blueprint or template. So let's say you have to build a house. So before building a house, what you do is that you design a house in the, let's say, using pen and paper. So when you are designing a house or creating a blueprint, that is not actually a house, that is just a blueprint. So that is a class. You can think of that as a class. And when you go on to build the house actually using brick and everything, that is the object. So the house that is actually built is the object, and the blueprint that was created on the pen and paper, using pen and paper, was the class. Similarly here, this is just a blueprint that okay, there's an employee, and employee will have name, salary, and will have the calculate salary. Now let's say there is an employee called Ram. So if I create the object Ram, we will see how do we create objects, and we will see how do we go with creating new objects. So let's say there is an employee called Ram. This Ram is the object. Ram is someone who actually exists. There is, you are an employee. Let's say I am an employee. So I am someone who actually exists. Employee does not exist. It's just a definition given to a person inside an office. So that's the main difference. Class only defines that these things should be there. So these are the features, these are the variables, and the actual existence of someone having those features is an object. So here employee is a class and Ram is the object. Employee does not exist. It's just a blueprint, but Ram exists in real life. Ram will have its name, salary, and there will be a method to calculate salary of Ram. So that is the main difference between classes and objects. So this is a class that we have created. In Java, you get lots of library classes, lots of standard library classes that you get, that you can use directly in your program, or you can create your own class as well. So this is one way of creating a class. This is the access modifier, this is the class name, and this is the class keyword, and this is the class name. And whenever you create an object from a class, so whenever I create an object, so let's say I do this, employee Ram equals to new employee. So this is how we create an object. So this is the object. So whenever we create an object of a class, we create an instance of that particular class. So object is also instance of the class. Now coming back to class, so you have various classes that Java already provides. Java library has various classes that you use directly in your program, and you also go on to create your own classes. Now let's go on to see that how we create a new class and an object. Okay, now let's see that how do we create classes. Okay, so till now we have already seen several times that how do we create a class. Now let's see how do we create an object. We will also see what object variable is, and we will also go on to see that what are the different characteristics of an object. So first let's discuss characteristics of an object. So the object basically has three characteristics. The object has a state, the object has the behavior, and the object has identity. Okay, so when I talk about the state, so before I talk about state of the object, I'll discuss about the behavior. So the behavior is that what can you do with the objects, or what are the methods. So in this class, cal salary is the behavior, that this is the method that we have. State is that how different variables of an object change, or the state of an object change based on the methods. So in this case, initially let's say my salary is 1000 and my bonus is 2000, and so initially my state is that name is let's say Ram, salary is 1000, bonus is 2000, and let's say I call this particular function calculate salary. So here after I call this function, what will happen? The salary will change to 3000. So this is the state. So what is the state of a particular object? What are the values that an object has at a particular point? So this is the state, this is the behavior, and by identity is that how one particular object is different from different object. So let's say there are two employees. So it's okay to have two different objects for those two employees, because they will have different name, they will have different bonus, they will have different salary. But there is no point of having two objects Ram, because Ram will have same salary. There's only one person, Ram, who will have the same salary, same name. So each object must be having some factor which is unique among them. So one object must be different from the other object. So these are the three characteristics of the object. Now coming back to this class employee. So I have this employee class. Now how do I use the this particular class? How do I make the object? So I will create a different class called employee test. Okay, so one thing to note here is that in a single .java file, I'm creating both the classes in a single .java file. So what happens is that when you create multiple classes in a single .java file, you have to make sure that only one class is public, and that is going to be the name of that file. So in this we have two classes, employee and employee test. And when I go on to save this particular file, it should be saved from the name of employee test.java. So there should be only one public class. In case you are having multiple classes, you can also have different classes for different files, but in case you are having two classes in the same file, you should have only one public class. Now again, here I have put it as public, which means the access modifier here is public. In this case, the access modifier is default. So we will talk about that how public is different from default and what access modifiers do. As of now, we are concentrating on creating the objects. Now let's say this is my public class. I will have a main function here. So whenever we have to create a new object, we use the term new. So if I have to create a new object employee, I will do this using new employee. So I have created a new object employee. So let's say this is the object in the memory employee. Now, how do I access this particular object? So we access this particular object using object variable. So I will create an object variable to refer to this particular object. So let's say I create an object variable emp. So now this particular object variable is referring to this employee object. This is the employee object, and this object is referring to this particular, this object variable is referring to this particular object. So how do we go on to create a new object? We create a new object using new employee. This emp is our employee variable. So our object variable. How do we create an object variable? We put the class name and we put the variable name. So this is, we are creating a new object variable, new object. So in this particular statement, we are doing two things: creating new object and making this particular object variable refer to this particular object. Now I have created a new object. Let's say I have to access this particular method. So how do I do that? I will take the object variable dot, I will call this particular method cal salary. This is how we access the method. In case I have to access the variables, we go through the same path. We use the object variable. These are the instance variables. I take its name, emp.name. So this is how an object is created and it is used. So till now we have seen what are classes and objects. How do we create a class? How do we create an object? Okay, here we are directly accessing the instance variable of employee from employee test, but it is not recommended to do so, and there are ways in which we can enforce that the other class cannot access our members directly, our member variables directly. We will see how do we do that. That's a part of encapsulation. Now, after object and classes, let's discuss another very important part of object oriented programming, which is a constructor. Let's see what is a constructor. Let's create a new class and let's see what's a constructor. In this case now, let's say I have these three variables and I want that whenever I'm creating a new object, then for that particular object, I want to initialize these variables. So let's say when I'm creating Ram, so I want that name should be filled with Ram, name should be initialized with Ram, salary should be Ram's salary, and accordingly bonus should be initialized. Similarly, when I'm making the object, let's say Shyam, so I want that these variables should be initialized as per Shyam's value. So I want that when I'm creating the object, the field should be initialized accordingly. One way we can do this is that using constructor. So we will be using constructor. So we will see how do we create a constructor, when constructors get called, and various things around that. So now let's talk about constructors.